You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
Hello, Chris.
Well, good morning, Nominisa. It's very nice to talk to you again.
Yes, hi. I remember we met briefly the last time I was here, and you explained my nervousness in the scientific way. I'm hoping today that you're going to help me understand what's going on with the Olympics. I've been watching a bit, and what's up with this swimming pools? They're changing. The water is green. Is it acid? Is it what's going on?
Yes, it's quite alarming, isn't it? And initially it was the diving pool, the one on the right. Now it's the water polo pool, the one on the left. So why are these pools going from clean to green? Well, the evidence is that this is a bloom of algae. Now, most people who've got an open-air swimming pool will have had to grapple with this problem at some time. Algae are single-celled microscopic plants, and that's why the water's gone green, because plants are green because they have the chemical chlorophyll in their leaves. These cells are no different. They contain chlorophyll. It's the chemical that catches the energy from sunlight and is used to drive the metabolism of these tiny plants. And they grow very fast. And the water is nice and warm because it's appealing to humans. You've got rain falling on the water, which is bringing in nutrients, including oxides of nitrogen, nitrates, into the pool from the air, which is helping to feed the water. And you've got lots of sunlight because it's an open-air pool with no cover on it. And all these are the perfect ingredients for the algae to bloom. And I presume either they've got a strain of algae that's a bit resistant to the chlorine, or because of the sunlight hitting the water, the chlorine level was allowed to dip a little bit. And that's allowed the algae to explode, and it grows very, very fast, and it's really hard to get out of the water because the particles are so small, and the chlorophyll that they contain comes out when the cells break down and gets into the water, stains the water green, and you can't get rid of it with the filter. And so they're going to have to now shock treat the pool to kill all the algae off with a big dose of chlorine. And then what they'll have to do is add some flocculating agents. These are chemicals, including things like aluminium sulfate, which are really highly charged particles. Aluminium, very small metal ion with a big charge, 3 pluses of positive charge, and it helps to stick things together. And it will clump all of the particles together, making them an easier target for the filter to drag out.
Now, let me just ask you. So basically you're saying that what we're seeing at the Olympics is not really that different from what we see in our own swimming pools in summer in Johannesburg and when it rains, except that it's a million times multiplied, it seems.
Yeah, it's on a grand scale, and unfortunately millions of people all around the world are watching them cock up their pool chemistry. So a bit of a faux pas for Brazil. They ought to have been watching their I mean, it's possible to stop this happening if you just keep the chlorine nice and high and keep the pH right. And it may be that it was a dose of bad luck, but it may just be that they were so stretched because they've got a huge event to run. These things occasionally happen.
That's very interesting. I mean, that's a disappointing explanation. I was waiting for something really very esoteric.
Oh, sorry, did I forget to mention that, that also one other theory is that Shrek is moving in.
Oh, okay. No, I was kind of expecting something like that.
Well, here's an interesting story as well this week. There's a paper come out in the journal Science. It's from University of Copenhagen researcher Julius Nielsen. They have found the oldest or the longest-lived vertebrate, in other words, animal with a backbone on Earth. Can you guess what it is?
No.
And how old it is?
No.
It's a species of shark. It's called the Greenland shark.
Yeah.
And get this, the species they were testing, they were caught by accident in fishing nets, so they used them for scientific purposes. Some good came out of them being landed. Some of them are 5 metres long. They got the eyeballs out of them, because the eye lens is one of the longest-lived tissues in the body, and they carbon dated it. Some of these sharks are 500 years old.
Wow.
Which is incredible, because we knew that whales could live 100, maybe 200 years. There are some bowhead whales that were known to be 200 years old, but a shark, 500 years old, that's very impressive. And it's therefore the king of the long-lived, this shark species now. And it's sort of knocking on the door of the reigning animal world's greatest long-lived animal, which is a clam, actually. 507 years old is the oldest clam, the shellfish that anyone's ever detected.
I'm not sure I'm very comfortable with the sharks being so long-lived. Let's take Tifo from Bedford View. Do you have questions for Chris?
Hi, good day.
Hi.
I have a question for the Naked Scientist. Yes, I would like to find out, why is it that every time when I eat spicy food, I get hiccups all the time? Is it an anomaly with my anatomy, or is there a scientific basis for this?
No, you're in good company. Many people who eat very hot food will say that they can get a bout of hiccups. Hiccups are a spasm of your diaphragm, which is the big dome of muscle that separates your thorax, where your lungs are, from your abdomen, where your guts are. It's controlled by your phrenic nerve, and the phrenic nerve is connected to your brainstem, where there are nerve pathways that decide when to make you breathe in, when to stop breathing, and when to make you breathe out. Hiccups are dear, oh dear. Hiccups are a pattern of nerve activity in the brainstem which triggers that spasm of the diaphragm, and the reason it happens is because, for some reason that we don't understand, you get this pattern of nerve activity going round and round in circles, creating the hiccuping. When you have very spicy food, you stimulate very powerfully the sensory nerves, which are in the same part of the brainstem from your face and mouth, and some of that sensory information spills over onto the areas that control hiccups and makes them happen. Not in everybody, but it's quite common.
Oh, okay, thank you.
You're welcome.
Let's take Hasi. Hello, Hasi.
Good morning to you. Morning, Professor.
Morning.
I've been watching tennis on the TV. Now, when there is a doubtful in or out of the ball relative to the side or baseline, they normally show the trajectory of the ball and where it lands next to the line. Now, the shape of the landing is normally given like an ellipse. Why do they show it as an ellipse?
Yes, you're referring to the Hawkeye system, and this uses a catalogue of cameras, or really a constellation of cameras, which are positioned strategically around the court, and they're tracking the ball with very high resolution and very high temporal resolution. So they're taking very high rates of pictures, and a computer model then integrates the contributions of all of these cameras to work out where the ball is travelling and where it will therefore ultimately end up. There are two things to consider. One, there's going to be a degree of uncertainty in the model, because obviously we can only make these measurements with a degree of uncertainty, and when you sum uncertainties together they get a bit larger, so therefore the ball shape is not going to directly mirror the shape of the ball anyway, because there will be uncertainties. And secondly, I think you could consider when the ball lands it's going to squash a little bit, isn't it, because it's going to flatten out. So that part of me, the sceptic in me, is thinking, well, it is part of the ellipse because the ball goes squidge when it hits the ground and flattens before it bounces again.
Okay, let's take a quick break. We'll be back with more of your questions for Chris.
702 and Cape Talk.
The Naked Scientist.
Welcome back. We are continuing with the Naked Scientist. My name is Nomboni Sokasa, Friday stand-in. Please keep those calls coming at 011 883 702. In Cape Town, 446 0567. Hello, David. Oh, Tabiso, you're online.
Hi, how are you?
Hi.
Hi, how are you?
Good, thanks. How are you?
Very well. Just a quick question for Chris. I just wanted to find out, if you're following a truck carries bricks, right? And the bricks fall off the truck. I mean, if one brick falls off the truck, the brick kind of goes in the opposite direction to the truck. In my mind, inertia should be moving the brick forward, but it somehow falls back. Why is that?
Hi there. Well, there are several things going on. You're quite right. The brick, when it is on the truck, is moving at the speed of the truck, and it has momentum in the direction of the truck. The thing the truck is also doing is holding the brick up off of the ground. Now, when the brick falls off the back of the lorry, then gravity becomes unopposed and it begins to pull the brick downwards. And the time it takes the brick to hit the ground is relatively short, because it's only a metre or so off the ground. And the brick is also not being accelerated by the lorry anymore, so it will begin to incur air resistance. It won't drop straight down, though. It will continue to move along in a certain direction that the truck was moving in, as well as falling downwards. So it's experiencing acceleration in the downwards direction, and it's also decelerating because it's experiencing air resistance. So it's just your impression that it is slowing down a lot faster than it is. You're just catching up with it, and it's encountering air resistance. But it is still moving along in the direction the truck is, a bit, as it hits the ground.
Okay, all right, thank you.
Peter? Hello, Peter.
Yes, good day to you. I wonder if you could help me with the issue of carbon dating. My understanding is that it is not absolutely accurate and that there are various ways or forms of carbon dating and that they might vary widely between each of them. Have you any thoughts on that, Doctor? And I'm going to listen on the radio.
Hi, Peter. Well, carbon dating was invented by a guy called Willard Libby. And the way it works, the simple principle of carbon dating is that in the atmosphere there is more than one form of carbon dioxide because carbon comes in several flavours or isotopes. There's carbon-12, there's also a form called carbon-13, and there's a form called carbon-14. Carbon-14 is made high up in the atmosphere when the outer atmosphere interacts with radiation from the sun and it produces an atom of carbon-14, and carbon-14 is radioactive and it decays or breaks down to carbon-12 again, and it does that at a rate of about a half-life of 5,500 years. So every 5,500 years, if you start with 100 atoms of carbon-14, on average you will end up with 50, and then after another 5,500 years you'll have 25, and so on, and that's called an exponential decay. And what that means is if you take a piece of something, let's say it's a piece of wood, that wood, when it was growing, was pulling carbon dioxide that had a certain proportion of the carbon dioxide was carbon-14 out of the atmosphere, and through photosynthesis was turning it into wood inside the plant. All the time that plant's alive and growing, it's bringing in carbon-14 at the rate that it's in the atmosphere, and so it equilibrates, becomes the same as the concentration in the atmosphere. But when the plant dies, it then doesn't bring in any more carbon-14 from the atmosphere because it's now dead and buried and in the ground, and this carbon-14 begins to turn by radioactive decay into carbon-12. And what this means is that if you measure the ratio of carbon-14 to carbon-12 in the object, we know what that ratio should be, i.e. what it was when that object first was formed and in continuity with the atmosphere. If the ratio is less than that, it must be older than the present day. And by relating what that ratio is to the curve I mentioned, the radioactive decay curve, you can make a prediction with a degree of certainty, uncertainty, as to how old that object is. There are limits on how far it can go back because eventually the curve flattens out so much that the differences, the noise, become so dramatic that you can't make accurate predictions beyond about 50 to 60,000 years. Once you get to about that point, it's not helpful and you have to use other ways of doing it. Other things to bear in mind, and radioactive or carbon dating researchers know this, in the 1950s and 60s, when there were nuclear bomb tests going on around the world, the world's background level of carbon-14 in the atmosphere went up because of nuclear bombs. And when you carbon date things that were born in that period, you can see what they call the bomb blip, which is an increase in the amount of carbon-14 in there, and you have to take that into account because if you don't, then you could give your thing the wrong age because it's actually for that brief period of time, if you don't take account for that, you're bringing in more carbon-14 than would naturally be in the atmosphere, and this means you had more to start with, so you might underestimate the age of something.
Andrew, you want to know?
Andrew, Pretoria. Yes, thank you.
Hello.
Morning, Chris. Morning.
Morning, Andrew.
All right. What I want to ask you today is about the sun, our sun, that we have been told what it consists of, hydrogen and helium and things like this. My information is that the sun is not a nuclear reactor that generates heat and light from its core and is not going to burn itself out eventually and head for destruction. Also, the sunspots don't come from the inside, but from the outside. When a ring called Taurus on the equator of the sun is overloaded with electricity, it discharges electricity and punches the surface of the sun, causing the sunspots. The sun is like an electric bulb. American engineer and electric universe researcher Ralph Jurgens supports this theory. Why is the sun temperature on the surface is 5,000 degrees and the corona millions of miles out is millions of degrees high. Thank you very much.
Yep. Well, an interesting point about the sun. The sun, as far as we can tell, based on the rules of physics, is a giant fusion nuclear reactor. It can do up in the sky what we can't do yet on Earth, and we're aspiring to do, because nuclear fusion offers a number of advantages over other ways of extracting energy, including fission. In the sun, you have an enormous amount of hydrogen, which under the pressure and temperature and the gravitational force of the sun, because it's so big, is being squeezed together sufficiently hard that 4 atoms of hydrogen merge to make 1 atom of helium. And so the sun is currently converting its hydrogen into helium. And when you do that, you create a more stable nuclear structure which surrenders some of the energy which it gains through that stability as photons of light, and photons of light are packets of energy which can warm up the Earth, and so that energy radiates to us and warms up our planet. It's quite true that in the centre of the sun you have the core of the sun is at millions of degrees. The surface of the sun is comparatively cool at some 5,000 degrees Kelvin or so, and you do get these sun spots, which are black blobs on the surface of the sun. They're called spots because they do look like spots. They're actually planet-sized. They're bigger than the Earth, each of these sunspots, very often, and they are relatively cooler spots. Scientists making careful measurements of the behaviour of the sun when these sunspots occur using spacecraft which are in orbit around the sun. These are observing spacecraft. There's another one actually going out soon to go and make different observations on the sun. Those spacecraft have found that there are disturbances in the magnetic field of the sun because the sun is turning incredibly fast and it gets itself sort of wound up into a twisted up state, and these knots of magnetic flux twist out and arc out from the sun's surface around these sunspots, and occasionally they can fling off plasma from the sun out towards the Earth's surface, and if that makes it through our own magnetic field, then it can interact with our power grids and things like that and cause these sorts of problems that were being alluded to. As far as we know, the sun is a giant nuclear reactor.
Thank you. Peter? Hello, Peter.
Hello.
Hello?
Hi, I want to ask the scientist question. Why do flying ants always come out after the rain? I listen on the radio.
Sorry, I didn't catch the question.
Why do flying ants come after the rain?
Well, they don't necessarily come after the rain. Ants have a certain life cycle, which is that you have a queen ant. The queen ant carries a lot of sperm from a mating with a male ant inside her body, and over a number of seasons even, she will lay enormous numbers of eggs who turn into the worker ants. The worker ants will build a nest. The queen will lay a whole heap more eggs in that nest, and those eggs will hatch into more worker ants, but also a number of queen ants and some male drone ants that can mate with the females. The idea of the ant social system is that when those are all matured, and for some reason and somehow they all mature together, and it's a good job they do, they all emerge en masse, and then the males and the females get together, mate, and they go and fly off and start a new nest somewhere. Now, it might be that rain is a trigger under certain circumstances because it heralds a certain time of year, because the ants will have a certain time when they all mature, because it's timed carefully so all the ants come out together, because otherwise they're not going to meet and mate, are they? But I don't think there's a direct trigger saying it rains and then they happen. It may well be that it's just you noticed it more at that time, but they don't depend on rain to fly, and in fact it would be bad for them if they came out in the rain, because a raindrop is big and an ant is small, and it would dash them from the sky and possibly damage their wings and prevent them from migrating off to start a new nest. So it may be that they wait until it's not raining before they do fly, and that's why you tend to see them more often then.